Well, hi, good morning. Thank you so much for joining me in my shop. Today is May 19th. It's a holiday here in Canada today. So, what about this radio? So I've aligned the IF. I think I did an okay job of it, and the result was a small improvement or increase in the radio's sensitivity and its output of the speaker. Actually, maybe a little more than the small. Maybe it's actually maybe doubling the audio strength of the radio, but it didn't solve any of the distortion problems at all. So the sound is still distorted, and it's still generally weak too. This looks like a monstrous radio to go in and start doing things like changing capacitors and stuff like that. Wow. All up in here, oh my gosh, I mean they're everywhere, tucked in very, very difficult places. And how do I know that would even do anything? I don't even know that. For all I know, every capacitor in here is just fine. I don't know. So what's the next step here? More alignment. So I read the alignment instructions for the next stages, and they're difficult and not to be undertaken lightly. So, but in the manual, there's another interesting piece of information. There's a chart that lays out the 2-pin voltages for the tubes in the radio. So you can take your voltmeter out and check to make sure the plate voltage is there and the screen and stuff like that. Well, I can do that without, without putting any risk to the radio. I don't have to take anything apart to do that. And although some of the tubes are hard to get at, others are not. They're fairly exposed. And let's think about this distortion situation. I'm willing to bet the distortion that I'm hearing is coming out of audio circuits and not out of the radio circuits. That could be starting right with the detector and all the rest of the audio coming forward from there. I think that's probably where the distortion is occurring. And that amounts to mostly these tubes here. The detector tube may be over here somewhere, I'm not sure. So what I'm proposing to do is to check the pin voltages on these tubes, which are easily accessed. I don't have to do it from underneath. I have tube extenders I can use to get at the terminals and go through and just test the voltages on these audio tubes in the hopes of finding one that's a voltage that's out. And that would explain the distortion in the whole shop. That's my plan for today. Okay, let's get started on that. Only a minute has gone by. I'm just looking at the radio and I notice these little things here. These are pins sticking up and they have a plastic surrounding around them. 1, 2, 3, 4, 5, 6, 7, 8, 9. These must be test points. These must be test points. Look how many are all around in here. I'm going to find out about these before I do anything, because these may avail me of an opportunity here that I'm not really aware of right now. I don't remember seeing anything about test points anywhere, so I'm going to check, see what I can find here. I couldn't find any reference to anything about test points or any diagram showing these things. Perhaps it's something that was set up for factory purposes that during the building of it somehow, or maybe during the initial alignment or something, these things are useful and then they're never referred to again. I'm going to look underneath and see if I can see what's going on underneath here. Let's see what we can find. There's one down in this area. I'm going to get my finger on it. For something like this, when you're looking like from through a cabinet, you can't see. My finger is on the test point, and I have a sense of where my finger is. It's right in here. And this is an easy way to Did I say easy? So the test point is right here, and I can see a structure underneath. Quite a number of red wires connected to it, and a resistor and other stuff. Okay, so I know what they look like. Now there's a whole pile of them over in here. Let's see if I can see them. Yep. That's exactly what they are. These are all test points where, for one reason or another, they brought something to the surface for testing and then not referred to it at all in the manual. Not a lot I can do with them unless I can spot them in the schematic. I didn't spot them there either. And if they're designed, for the building of the radio, and that they may not have much value now for me. I just go back to what I was going to do, because there's only so many of them, and I don't know what's what. So I will get the tube extenders out. We'll extend these up and test the pins. And I don't know. This is a. Let's see if I got a big extender here. Well, there are certain things, not only here in my shop, but just in my life in general. I'm sure it's true for you too. Certain things you never want to misplace, like your wallet. You sort of keep track of where you've put it and where it is, all that kind of stuff. Such is the case with my tube extenders. These are things I carefully put away in a special drawer to make sure I don't lose them. I got 3 of them. I can't find one of them. So this one's not going to help us, I don't think, at least not at this point. This one's good for these 2 tubes. These are large tubes, lots of pins. But the extender I need to do these, I don't know where it is right now. But maybe we'll find out the problem is here. Maybe. So what we'll do is we'll just pick any one of these. V14. Pop in the extender. Pop the tube in. So the idea is that this gives access to all the pins for testing. There's little contacts here. They're even numbered if you get up close. You just go around and do the voltage test on it. Okay, I need to. I think I'm going to print that chart out. Let me do that. And time for coffee too. Okay, so you can see my cat is sitting on the sheet now of values that I need to refer to. I guess he's studying them first. And we're going to turn the set on. Plug it in. Bert, you've picked the fine time to come here and join me. Back this up a little bit. I'll be using this voltmeter here. Have it set to 150 volts. Bert, you need this piece of paper. Thank you. We're doing tube 14. Tube 14. Got a 14A and a 14B on this list, so I guess it's a 2-part tube. Pin 1, 26 volts. Let's see. Anode, pin 6, 212 volts. That's odd, eh? And no screen voltages, as it listed here. Anode, screen, cathode. Gives you the cathode. This must be the bias voltages that you would get here. And V19, the cathode voltage is 262 volts. So that's probably a cathode follower arrangement. V19. V19. Oh, that's the rectifier. Yeah, stay away from that. 242 AC. I'm just reading over the chart, make sure I'm familiar with it. I'm not to try to reduce the number of errors I'm going to make to a minimum. Again, V14. Let's just practice a little bit here. Pin 1. Spot pin 1. This is 1. 1, 2, 3, 4, 5. Good. I think I'm ready. Here, you can study this, Bert. While I turn on the radio here. No, that's not the switch. Maybe it's this one here. Oh, I haven't got the power bar turned on. That's what's going on here. Okay, let's try that again. And this time I'll actually better look. Let's see. It's a mains switch. Must be made in Britain or England or the UK or somewhere over there. How come you guys have got some kind of Venn diagram going on in the UK there to try to, you know, understand these England, UK, Britain. So I guess we left it on FM, and it's tuned near a station, which is fine. Okay, so here we go. Just okay. 14. Pin number 1 should be 26 volts. Let me shift to here. Oh, he's gone right over to the voltmeter. Isn't he so smart? He's a smart cat. And he's walking on my keyboard. It's not so smart. Okay, here we go. There we go. Pin 1, 26 volts. There's pin 1. That's a 50 volt scale. On my meter, it's 31 volts. Okay, there's a plus and minus 10% on this. In these readings, something like that. Okay, so the next one would be nothing. There's no more to read for 14A. 14B, pin 6, 212 volts. So a 500 volt scale, pin 6. 1, 2, 3, 4, 5. This should be pin 6 here. I heard the radio go quieter. A voltmeter on a plate circuit shouldn't do much. So on the 150 volt scale, we've got only 100 volts here, and we're supposed to have 212 volts here, and we've only got. Let's say it again. So this is a problem right here. We've got something right here. You know? What are you chewing on over here? Just found more clip leads to chew on. Just love chewing the clip leads. So I'm just marking on the sheet here that this one is actually 100 volts. This is probably the problem. 100 volts where you should have 212, that is definitely a problem. And we're definitely on 150. Definitely around 100. Okay, there's also another reading on this tube we should find on pin 8, 35 volts. The pin 8 would be this one. Pin 8. That's a 50 volt scale. We got 35 volts on it. So we're looking at a loss of plate voltage on this tube. It's hardly worth going any further until this is resolved. But this is probably it. Oh my gosh, the music's playing. I'm going to get a copyright hit even for this scratchy stuff. Talk over it, Jim. Keep talking over it. Hit the switch. Do something. Get it off there. So a copyright hit can really mess up a video for me, and I'm not against copyrights. I understand the system. It's designed to make sure people can't hold the rights to something forever. Copyrights break your rights after a certain number of years. Did you know that? People think copyright is about protecting the holder of the copyright, but in fact it's limiting his ownership of whatever it is, the idea, the patent, whatever it is. It's to limit it and to turn it into something that's available for everybody, usually after roughly a lifetime. So like you invent something when you're 20, you probably can keep a patent or copyright on it. Do I know what I'm talking about? No, not really. Oh my gosh, look what's going on over here. I'm getting ganged up on. So they give me an opportunity to explain why my shop is a mess. It's not me, it's them. It's not me, it's them. Believe me. All day long, trying to increase entropy, So I've been smart now. I've learned to turn off my keyboard when I'm not using it, so when this happens, nothing happens on my video here. Okay, going back to the radio now. If I did suffer from copyright interference, I may have had to chop this video a little bit and maybe a little jerky in the last couple of minutes. But anyway, I found the plate voltage to be low here, quite low. It should be 212 and it's coming in at 100. So we're going to look into that problem right away. My guess? Resistor's gone high. That's my guess. Okay, well, by now the coffee should be ready though, so I'm going to get a little coffee and then we'll carry on. But you guys, aren't you done yet? Have you not seen enough over there? How about jumping down? How about oh, no, we're on the move here. I'm here. Wally. They don't know their names yet, but this guy is Wally. He has a white patch on Wally, whereas Bert, his brother here, no white patch. He's patchless. They're named Bert and Wally because they're actually named after nuts. Because our last cat's name was Peanut, we thought we'd try to carry on the nut naming convention, and so Wally here is actually Walbert. Walbert. No, he's Walnut. Walnut? I'm confused. But Bert here is from what kind of nut? Filbert. He's from a Filbert. But we didn't want to call him Phil. We call him Bert. Wally and Bert. There we are. Two nuts. Oh, you guys. Really? Thanks for the help. Really appreciate it. I'm gonna go have some coffee now. Hey, you know what? You're gonna chomp something here and find out. You're gonna get a lesson you don't want to get. Okay, come on. I'm extracting. A cat extraction's taking place here. This is a cat extraction. This is what a cat extraction looks like. Whoa. One down. Yeah, you're next. Fun with cats. Who needs a radio if you have cats? If you have cats down here. Yeah, great time. Okay. That's enough for the cat show for now, guys. Okay? That's enough. I've had it. Cut. Brennan. What's that what they used to say? I think I made a video error just now, unfortunately. What we really want to look at is the... Yeah, I'm sorry about this. I gotta redo a few things here, and I do not like going back over something. But here we are. This is the tube I was testing. I can see in the plate circuit, there's a capacitor off to the side here, blocking, protecting the grid here. Come up a resistor, a capacitor, and a resistor. And what I've done is I've printed this page, and then I've gone on the parts list and picked off the values, and this one is surprising. This might be the problem here even. Let's take a look here at what I found. Okay, here we are. So this is a 0.01 capacitor here, nothing surprising there. 100K resistor here, and a 27K resistor there. What's surprising is this capacitor is a 4 microfarad electrolytic capacitor. What if this guy is shorted out? It's not particularly likely, but what if it did? Well, if this shorted right out, you'd have no voltage here. If this was somehow drawing current, which I have trouble understanding how that could happen, but if it did, it would increase the voltage drop here and not leave as much voltage for down here. Far more, and this one here, if this one were to short out, you're shorting out through this resistor, I don't know the value of, down to the ground bus. I just, if this were shorted, I have the feeling we wouldn't hear anything because of the grid voltage here would be way off. But the most likely thing is this resistor's gone high or this one's gone high, one of these two. That's the most likely thing. Well, those are all the possibilities. So let's see if we can find all this now in the bottom of the radio. That's the next challenge. Down under this. Okay, I'm gonna have to set some stuff up for that. Okay, well, that's about the tightest spot to get to in this radio. Way up in here. The actual tube is this one here. So I've got my other camera ready. We're going to try to look at it up close here and make sure I got the right tube. And see if we can't start identifying a few of these parts. Okay, let's switch to that camera there. Now I'm going to have to fix the focus on it because you can see what it's going to pick, you know, kind of randomly what to focus on. So. And plus this camera, you can see it does a lot of focus hunting, especially if there's a pattern in view. If there's something with a checkerboard or pattern, it really can throw it off. Okay, we're going to turn off the auto focus. Actually, it's not too bad right now. Now, is that the right tube that we're looking at? Make sure by putting this stick here. This is the tube socket. Yeah, you can see my stick going into it. There it is. That is the guy. Now, there's too many resistors here. What I'm looking for is let's say a 27K. So that'd be a red, purple, orange. Red, purple, orange. There's a couple of resistors tipped on their sides there. Orange third band. None of them have an orange third band. Let's see if we can see these ones on the side. Oh. So, they don't have an orange third band. Oh, there it is, right up here. There it is. Oh, my stomach. Look, it's going from a test point, I think. I think that's a test point. Up at the top there. I'm not sure, though. But anyway, there's the resistor. Okay, that's one of them. Hey, it looks nice. Now, the other one we're looking for is 100K. That would be brown, black, yellow, I believe. Well, there's a brown, black, yellow right down there. And it's connected to the same point. And these two resistors are tied together. At the tie point, there's a capacitor. It's that white thing down there. So that's a capacitor, eh? The grayish colored thing. Well, there's the parts. Who's the troublemaker? So the parts are in place. So when I go to do a resistance test on them, they're in the circuit. So it might not be as declarative as we would want. And my voltmeter has wandered off another part of the house. I have to go and get it. So let me do that. Okay, so I'm on the 600K scale, just checking my meter. Oh, you know what? I can use that test point. I can use that test point. That test point is the connection point between the two resistors that I want to test. So, if I can clip onto the test point, that's going to make it really easy. And I just have to put one probe in the back of the radio. Let's first check this clip lead here. See if it's 0. Yep. Okay. Now, which test point is it? I think I know which one it is already. Maybe this one right here. These test points are nice. You put a clip on them. They're nice and big. They have a little insulating ring around the bottom of them. Very nice. Okay. This first one then is the 27K. 28K. And the next one is the big guy. I think that's it there. Ooh. More than 600K. Supposed to be 100K. Let's try again. It's reading 100K, isn't it? Why did it not work? Maybe I got the probe in the wrong spot here. Yeah, there we are, 102K. So that's not the problem. The two resistors are good. Phooey. Although, wow, trying to replace them down there. Now there was the capacitor that runs, it's right here. This capacitor here goes to ground, and I'm reading to ground, so that didn't. So if this were shorted or something, we would see it. And if it's not doing its capacitive job, I don't know, would we get what we get? This kind of crummy sound, and that capacitor in there does not look like an electrolytic one. It's a little tiny thing. So we're left with this capacitor. How are you going to do this? We have to find if I read from here, which is from here, if I read from the end of this resistor, I'm reading this way and this way. Or normally there'd be nothing going this way. If this were shorted, and I don't think the radio would work anyway, then we would read a resistance through here of R73. R73 is probably a big whopper. Let me take a peek myself here. Let's see if I can find it quickly. R73. Oh my gosh. Okay, here we are. R73 is 500,000 ohms. Not quite as big as I thought, but still big. So that's 500,000 ohms there. So if this were shorted, you'd have 500,000 ohms in, not really in parallel with these, not really. So I've read from here to here. I've never read to here or to the chassis. So if I put the tester on the bottom of this resistor, read to the chassis, I'd be reading through here. I should get a 0 or open, like I shouldn't be any current flow here because of the capacitor. But that, so if everything's normal, I would read. What would I read? Because I don't know what I would read. Yeah, because let's try it and see what happens. Then we'll worry about the values. So this is the easy thing. Just clip to the chassis and repeat the test. Let me just check my ohm meter again. Let's go to 0. Yeah. Okay, so now we're going to read on the 100. Okay. So we're getting through a capacitor there. We're coming up to 150 ohms, 150,000 ohms. 150,000 ohms. What did I actually read there? Well, I didn't read down this way because that's 500,000. 150,000 would have to be read up this way. I don't know how this would work reading it to the chassis. I don't know what to expect. I'd be going through a winding down here or something. I don't know how that would work. So the test is just bogus. It doesn't really mean anything. So unfortunately, at this point, I haven't found any reason for this to be low. So what if this guy, if I read this point, wait a minute, I read to the chassis, I was reading basically through this capacitor. That's why I was getting the charge up effect. So it was this capacitor charging up. What if I attempt, I can't really read the value of this capacitor with anything, any instruments. I can put an ohm meter here and test to ground. And I don't know how to, I don't know. Let's do it. Let's do it. Sometimes it's better to do things, get a result, and then think about it. And think about what the result might be. So once again, we get on the right test point. It's right here. And then read this to the chassis. And we get a charging up capacitor and stopping around 40K. How do you get 40K out of that? You can't come this way through a 100K resistor and get 40K. You have to go up this way. I suppose I can read from here to the chassis. I should get some kind of difference out of that, shouldn't I? I should be able to eliminate the 27K if I do that. What's he talking about? He doesn't know. So if this thing is reading as an open circuit and not leaky, then all that stands in this test is these resistors. We know it didn't go this way. It must go that way. 50K. How do you get 50K? There got to be another, 25K in this line. So test the test point. No, this is the test point. Test the other end of this resistor. The other end of this resistor, it comes up on this bar, this bus bar here. Just this bus bar right along here. Is this radio still plugged in? It is. Jim, don't be fooling around there. Pull that plug. So I would read the bus bar, which is basically this, I believe. Read the bus to the chassis. Okay, stop thinking, start doing. Read the bus to the chassis. Read the bus to the chassis. So we'll put this on the chassis again. And the bus. Big capacitor charge up. Looks like it's going to stall out already. Okay, so in this test, we get 15. When I go to the other side of a 20, I'm sorry, what was it? It was 27K resistor. We should get 15 plus 27. That's just under 45. That's like 42. That's what we got last time, wasn't it? So I can just go over here now and do this. Do we get 42? Yeah, we're going to come up on 42. So I think this is an indication that the capacitor is okay. It may not be 4 microfarads anymore. Let's not short it. So where are we at now? We're at the point of suggesting this entire line is low. That can't be. That can't be, can it? You can see red wires coming to the end of the bus here. This has been fiddled with. Oh, another little piece of information that I have got for sure now. There's a diagram in the service manual shows the parts on the top of the receiver, including the output transformer. The output transformer is different than the one that's on here. So once again, that's lots of strong indications here. I don't think there's any doubt. Output transformer got changed, and when they did, they disabled some of the output features of this radio because the new output transformer didn't have them anymore. So the 600 ohm outputs, all that stuff, nothing hooked up to them. They've been abandoned. So could it be what happened here is somebody put in this other output transformer and the radio never worked right after that? It's a fair bit of work to do that. Would somebody walk away from it after doing that? I can't. I have trouble with that. Is somebody going to put a lot of effort into it and then just give up? When they themselves know what they did, they would know what kind of dumb things they did. Can we figure out what dumb things were done? This white wire is heading up to the center tap on the output transformer. You can see it. And then there's two wires coming back. One there. Wait a minute, only one. Let's take a look at this output transformer deal more closely here. Let's do this. Too many wires hooked up. I've swung this around the wrong way, I think. Take this off here too. What's holding it? I don't know what's happening there. Something was holding it. Let me have their foot on the brake. There we are. This guy here. So I've seen the output connections go straight to the two terminals you see I have this hooked up to. Now I hooked up a 2 ohm resistor here, 2.5 ohm resistor, because the output says right on it 2.5 ohms. But that's for the other. That's for the other. It's for the other transformer. So is it a chance I put this on and this is what's causing the problem? All this time I've had this resistor here thinking I was doing the radio a favor. But in fact, this resistor is the problem. I have trouble believing that. I have no reason to think that. How can you determine the output impedance of something like this? Can you just take an ohm meter on it? I don't think it's that simple, is it? Is it? I know sometimes the speakers will say 8 ohms at 1,000 hertz, and so what they're indicating is that it's an impedance that they've measured. Man, most of the impedance is resistance, maybe. Okay, let's try it. Let's stick the ohm meter on it. I can't say I've ever really done this. So we're going to be looking backwards. Very low resistance, I would think. Like, what do I hope to see here? 8 ohms? What do I hope? Half an ohm? That ohm meter just doesn't go any. It's going down. No ohms. Just read 0. Well, I don't have it. Yeah, I do. What am I saying? I was going to say I don't have it hooked up to a speaker, but I do actually, and it's probably around 8 ohms. I don't have any reason to think it isn't. This is it here. We'll take the resistor out. Can I clip these on here? The resistor was giving me a nice place to clip to. I don't think I can clip this. Well, they can go underneath. Go under here. Do we dare try to get at that? It's these two. Hey, wait a minute. There's a lot of parts on here. There's parts on here. Let's take a close look in here. I can't say I ever really looked at the back of this very closely. And for some reason they put the antenna connection right among all the speaker connections. Why would they do that? There's a special plate here. I don't know. Doesn't matter anyway. Okay, let's look in there. See what we can see. If we can see anything. Okay, let's just. So I'm going to put a stick on the terminal we're interested in. It's this one here. But it's not even in view of the camera. Here we are. Okay, the stick is touching the one terminal, and the part that got me by surprise, hard to see in the camera, this black wire. Where is it coming from? What's it doing there? So again, it's hard to see. Let me move the camera around a bit. Okay, now you can see this black wire here is coming from the output transformer. Look at it, it's a line. It's a piece of line cord, the lamp cord, and the other wire is this one right here, coming from and going to this terminal. So that's all I would really expect. Come from the output transformer to these two terminals. But look, what's this black wire doing here? It goes into a wire bundle. Oh my gosh, why? And look at this wire bundle. What is going on with that? Something I haven't commented on, but they've done the classic wrapping here. They've used some kind of rubbery plastic stuff. Whoa, it's broken there. Oh, broken here. Broken. We follow it along here. Oh, broken. All the way along. It looks almost like it's been melted. Like somebody took when somebody taken a soldering iron and just melt those things away. Let's look at that one a little closer there. Just give me a second. I'm gonna maximize the close-up focus here. Right, and take a really good look at it. Oh, what happened to that? They all look really weird. And then these ones are all broken. Look at this. And the other question is, why would anybody do this? Here's an end back there. Well, why would somebody do this? I don't know. It's just a curiosity to me. Now, if we come down way down low here and look at this one, these are all just perfect. All the way along here. They're all perfect. So I don't know what to make of that. Just an observation without explanation. And back to what we were doing. What the heck were we doing? We were. Oh man. We were chasing this black wire down. Yeah, let's chase down the black wire here. It's going up the back. Where's my flashlight? Up the back. Ooh, it's getting inside the bundle here. Okay, black wires coming out way over here. Any black wires coming out? This one right here. There's one here. It's kind of a dumb way to do this. And then the bundle just goes way up into the front. Why would they bring something from here way up into the front? Hey, schematic. Now, even though this has been altered, he may have reconnected that black wire. I don't know. Let's look at the schematic here. Okay. So again, this is showing the way it was. That's this here. This is the way it was. So what they've done is they've switched this transformer for one that has only one secondary, and there's a black wire that's been brought out. You know, it could be headphones. Could be a headphone line. Is there any black wire, any wires leaving? Well, it would be maybe from here. He would be imitating this. This is grounded. Okay, so they didn't fully isolate the output here. They grounded one side of it to the chassis, I guess. Where else would they do it? Okay, this is all disconnected. This headphone thing was lost when, I guess, when this was put in. The other side, like, you know, what would have happened to this and this? I think it's all. This be? Have you done something stupid with this and causing distortion? Trouble. I'm figuring that one out. How would this cause distortion? Well, who's to say the output transformer is in any way appropriate for this radio? Who did this work? Was this done by a guy like me, or was this done in the factory? I think if it were in the factory, it wouldn't look like this. They wouldn't have used lamp cord. The lamp cord indicates that somebody like me did it. The guy took his best shot at it. It didn't work, and he walked away. And why would he even? You know, the output transformers can fail. Anything can fail, but it would take a lot on my part to condemn an output transformer. So this output transformer is intended to produce this kind of output here. The one that's in there is not. Does that have a bearing on the kind of winding in here? Could this winding, could the winding here be responsible for a loss of B plus on this tube? No, we're too far away. We're way too far away. Way too far away. It would also be, it would drop it here, it would drop it everywhere. Is that possible? It's dropping it everywhere. It's just pulling it right down. All these tubes are low. Jim, you gotta test more tubes. Because I tested the other plate on this one, but it's not receiving the normal B plus, but all these ones are. Test more tubes, and Jim, find out if it's up here. The test tubes, I can actually test this voltage. Now I know what I'm doing, and and this is a test point, easily available, and I can even just test this, because I know this is a bus running through the back of the radio now. Okay, that's it. Test more tubes. Okay, I think everything is set up here. Let's get rid of that. Switch on. So I've removed the resistor load on the output transformer. I still have a speaker connected though. Here it comes. I have this desire to find out what happens if you hook up an antenna. Here's one now. I don't think I have the switch on, and this is really a shortwave antenna I've hooked up anyway. There's a little bit of wire. We'll tune. Okay, let's try a better antenna. Oh my gosh, it's better with no antenna. What I'm hooking up now is a typical FM folded dipole.
Start, but I also never had the urge to stop. So, and then at some point when I was, 15, and I was at this
lots of volume.
And then things were kind of going very well.
Taking that resistor off helped.
And then I started also really loving being in this environment and being very stimulated. I think I do have ADD to a certain degree, and I think it's a really great field to be in. I think if you have a little bit of attention deficit, just because
So I'm going to tune in the station with a bit of music
stimulated physically.
and see what it sounds like. So again, I don't hear that the limiter is doing its job. And I can hear the distortion, especially in the S's. So the problem remains. That's why we're looking. Okay. And did I have the IF turned up? Yes, I did. I did not adjust the trimmer. Let's just... Not making a lot of difference. Okay. Very good. Is it good? I don't know. We're going to find out. Now we're going to read the B plus voltage. We could repeat it on the tube. It's a little awkward for me right now to get to it. Maybe if I swing this way. Can we swing it this way? We're going to swing it all the way around. And then I want to hit number 6 here. See the meter? She's up at, so we're on the 150 scale. It's a 100 volts. And again, it's supposed to be 212. So it's the same thing, it's 100 volts. So now we'll swing this back. Look at that bus voltage here. Okay, I'm going to put this on the 500 volt scale. Before I do that, so on the 500 volt scale, we're looking at 225 volts. So somewhere 125 volts is disappearing on its way to that plate. So if we track through the resistors, the 27K leads to the test point up here. Attempt to test. Okay, you can't see it, but I can. That's reading 200 volts. Just losing all of its voltage, crossing the 100K. That starts suggesting the tube is conducting too much. That's another whole angle here. I never made it all the way across, or did I? I did, didn't I? Cathode reading, I think I did. I got 35 volts on the cathode. 35 volts on the cathode. Well, that would suggest everything's okay in terms of the current flowing through the tube. Get that flowing through the tube. What am I missing here? Pin 8 should give 35 volts. Pin 8 should give 35 volts. Okay, that's on the 50 volt scale. I better hit pin 8. Oh, it went. Pin 8. 35 volts doesn't say negative. I didn't get 35. I didn't get pin 8. Let's come back over here. Nothing there. What's going on? Pin 8. Meanwhile, pin 1 should be 26 volts. So pin 1 is 32. It's a little high, but it's there. Let's go back to this. I never tested this. The cathode voltage, cathode 35, pin 8. I'm just reading this chart here. That's what I'm doing. Pin 8. No question. Oh, wait a minute. I'm not reading this right. Wait a minute. ruler, please. Like a green one. Do you have a green one? I have a green one. Yeah, I was slipping down and reading the wrong value. So it says don't test it. Pin 3, no reading. Is that supposed to mean 0? It just has a dash. So all we get is pin 1. Wait a minute. No, got it wrong. Got it right now. Okay, now I'm right. Pin 6 reads 100 volts when it should be 212. Yeah, and pin 8 should be 35 volts. Okay, let's check it again. Pin 8, 35 volts, because there's nothing there. That doesn't sound good. Pin 8. Oh, I didn't test pin 8. I don't think I tested. Okay, it wasn't pin 8. It was not pin 8. Four, 5, 6, 8. Yeah, it was on 9, not 8. Okay, here's 8. There's 8. And we've got 35 volts on it. Oh, I thought I was on my way to something. So we've got everything is right except the one resistor appears to be dropping way too much voltage. We can prove that by reading either side of that resistor. So this is sort of the input end to that resistor on the 150 volt scale. How about on the 500 volt scale? So this is through the 27K. There's the test point. 100K plate. So the 100K has 200 volts on it. 200 volts, but on the other side of it, it's 100. There's going to be some kind of drop there. I have to calculate it, maybe. What would you expect? Write the tube type there. Tube 14. What are you? They didn't write it on here either. So tube 14. Let me just look at the diagram here. Somebody's going to tell me what tube it is. Somebody, somewhere. Here we are. Tube 14. Oh, ECC 82. Okay, well that's not going to help me too much. What is an ECC 82? Oh my gosh, how can I ECC 82. Okay, I'm just going to jump on the internet here and ask Mr. Internet. ECC 82, same as 12AU7. Oh, that's right. That's right. 12AU7. Okay, I remember now. Good thing I remember now. Okay, 12AU7. So looking up at 12AU7 for typical current flows and stuff. 12AU, just to get an idea. What just because I don't know what else to do really is the truth of it. 12ATU, 12AU7. Maximum ratings, characteristics, plate voltage. So if we were running it with 100 volts, grid voltage 0. What are you talking about? So we run it at 250, which is probably where it's really supposed to be, up around 250. It's supposed to be 212. You know exactly what it's supposed to be. The grid voltage should be minus 8 volts. What of it? How's this helping? I want to know about the current flow. Plate current, here it is, 10 milliamps. That's easy to work with. So 10 milliamps. If you have 10 milliamps going through a, what size was that resistor again? Going through a 100K. Well, that's really easy figuring, but I need a calculator. I need a calculator. Where are you? Mr. Calculator. Here we are. There we go. Here we are. Super modern calculator here. So I want to say 10 milliamps through 100K. So we take the milli, take the K, throw them away. And now you're looking at E equals I. We should take. boy, I tell you, man. Well, it's been a long time since I've been in college. Not that this is really very demanding. I think I better just work on a piece of paper here. So we know the current and we know the resistance. We want to know the voltage drop. So V equals I over R. Isn't that right? To get more I, you need more V. Get more R, you got less. Okay. Hope I'm doing this right. So the I is 10. And this doesn't make any sense what I'm doing. This is not right. I've done something wrong there. I'm doing something stupid. Something stupid, come on. How stupid am I? I times R. 10 times 100,000. Okay, so 1,000 volts dropping across that resistor. You know what? You know what this says to me? Jim, go drink some coffee here because you're losing control completely. Okay, new theory. New theory. Theory would be there's, despite what I found here, just ignoring all that, there's nothing wrong here, and the problem really is happening over here, and it's because this guy is leaking. That's my theory. And so we would find a positive voltage at this point. That's worth looking for before going any further. That doesn't explain anything about what's going on up here, but we can look for this voltage here. And this would be, I'm going to figure out, this is another 1287 grid voltage. Well, there's that capacitor coming to it. Oh my gosh, this might be hard to figure out. But that's what I'm going to do. I'm going to try to test this grid on the far side of this capacitor, which is attached to right in here. Maybe I can. Okay, enough talk. Okay, it's taking quite a bit of time to sort this out, but if you look inside here, you see the two reddish-orange capacitors I'm highlighting with the flashlight here. The upper one is feeding the signal from the tube I've been investigating to the next tube. This is the capacitor that, if it's leaking, would upset the grid of the next tube. So that's where I want to test and see if the grid of the next tube is positive. So I have to get my probe down in here. And then when I get it there, I have to look over. Oh my gosh. Can I get it right on? So they put spaghetti on the end of the capacitor. I don't think I can get contact there. I need a needle on the end of my my guy here, because putting this down into all that, I don't think it's going to work out. Because it's really buried. Oh, I could use the tube extender. Tube extender. Okay. Okay, that's what I'll do. I'll extend the other tube and then test the grid. Okay, so I've moved the tube extender. Let's turn on the radio here. Wrong switch. Here we go. 2 and 7. Okay, now I'm going to take this off because, oh no, I got to leave this on because I want to be able to hear Maybe move it to the other side. I want to be able to hear the radio working because it keeps me mindful that I've got a operating radio on my bench. When it's silent, I can forget that it's on. Stick my finger in somewhere. I'd remember then. Okay, so the two grids are 7 and 2. 7 is the one that I believe is the one we're after. So let's start with that one. 7. So I'm just looking at the pin numbering here. There's 7. Right there. Okay. What we want to see here is either 0 or negative voltage. So this is 1.5 volts. And we have a small positive voltage here. And the 0 is off. How did that happen? Okay, we'll try it again, but we'll get the same reading basically. Make sure I'm going on 7. That's 7. So, you know, that's about a third of a volt or something of that sort. Positive relative to the chassis. I really need to make this test relative to the cathode. Cathodes. There's 2 cathodes in this tube. So we have to get the right cathode. So if it's cathodes on 8 for grid 7. So measure between 7 and 8. The negative lead on 8. Using this meter here. We would expect the negative lead on 8 to get a 0 or a negative reading. Negative reading would be what we're really after. So this goes on 8. 8 is right. Let me make sure I get this right. 8. Right there. Don't rotate. 8. What did I say? 7. Right beside it. Right beside it. Okay. What does the meter say? Minus 4.6. So that's it's not going to make me cry. It's a negative voltage on the grid. It's a little less than what it should be. You know what we'd have to do? We got to put the scope on this stuff and see. Is this clipped hard enough to even spot? Let me turn it up and tune it maybe. This has gotten worse, hasn't it? So far I haven't found anything really out of sorts except the plate voltage on this tube is way off. Haven't found any reason for the plate voltage to be off that I can understand. We're going to go back to that plate voltage problem. Plate voltage problem. How can it even be the way it is? I already looked at what kind of voltage drop would happen on a resistor with 10 milliamps going through it. Did I get my resistances mixed up here? I don't think so. No, 100K resistor with 10 milliamps going through it produces 1,000 volts. Just well, what that would mean then is there isn't any 10 milliamps flowing through it. Now, you know why that could be? What if this grid is way off? So what are they doing here? It looks like they're just, I'm not sure where the signal is here. It's becoming, see, the noise thing is involved in here somewhere. So, well, assuming this is the signal, yeah, this side is the noise side, and this side is the regular radio side. So we follow this grid back. Here, come through here, so we got We got a capacitor there. Now what's it protecting from? Come all the way down here. We're getting into the volume control and off the page here. And the volume control appears to be protected by a capacitor right there. So trying to reason out a incorrect bias on this tube, we should measure it really, but yeah, I can't come up with a believable story of how that could be really. So we can put the scope on and look at the stuff, and we can also use the signal tracer and listen to it. I think we should look at it. Now, maybe we should start right at the volume control and see what the volume control is producing, or listen. We should really listen to the volume control. We should listen to the volume control. Everybody. So the volume control is here, or here, this one. Once again, very hard to get at up in there. Yikes. The volume control wires will wow. If I could find the other end of these wires. Wow, that's, yeah, I'm not sticking a probe up in there. What was I going to do? I was going to listen to it. We listen to the input. Well, okay, so well, I have to get the other diagram to find out a better spot to pick up the signal reaching the volume control. What about leaving the volume control? Why not that? For leaving the volume control, that'd be just as good. We have to get, so it comes up, falls a shielded wire off the volume control. Shielded wire from the volume control. Yeah, there's one in there. It's in this bundle. Yeah. Where's it go? So it goes all the way over to this capacitor. Oh my. And then near this tube. Uh-oh. Wow. Trying to spot all that. The best way would be to listen on the grid here. So this is another 12AU7, the same pinout. They've got an A and a B and an A and a B. I wonder if it's the same for both tubes, you know what I mean? So this grid would be 7. So if we look at or listen to 7, we should listen to 7. Listen to grid 7 on V14. Did I already do this? I have this feeling I've done this already. So if we V14, I want to listen to the grid on V14. So I'm going to move the extender back to where it was before. Okay, so I've extended this tube, V14, and that would make this grid available on pin number 7, I believe it is. It's one of the 2 grids. So we should listen to one of the 2 grids. I want to listen to it with some fidelity, but I don't really have the option of doing that. I could just use my signal tracer here. Probably the best thing I can do. Ground that, and then I would take this. The set is off right now. We take this and we want to go on 7, and what was the other grid, just in case. 7 is the one I think it is, 2 is the other grid. 7. So we want to go on 7. And practicing here. 7 back here. Can't get there. Can't get there. I can't get there. I'm gonna get there this way. Pin 7. Yeah, I can get there. That's pin 7. Just coming on a bit of an angle. I won't be able to hear it. Okay, radio on. Radio on, not there, here. Radio somewhere. One of these switches will do it. Yep, that's it. Warm up. That sounds like bad tuning pretty well. That's as good as it gets right there. Okay, cutting the volume out on the radio. Relying now on this. This guy's set to audio. Volume down. Pin 7. Yes, it was 7, but I'm so yeah, it is 7, definitely 7. Okay, going on pin 7. Absolutely sure that is it. What do we hear there? Some kind of squeal. I didn't hear anything there at all. Hey. What happened to the... Oh yeah, turn the volume down. Oh, you can't turn the volume down. Turn the volume up. We'll disconnect this. Okay, if it comes out in English on this, that'll be interesting. Now that would be something. Here we go. Okay, we're on pin 7. Sounds just as distorted, doesn't it? That gets us somewhere. I've sort of done this way back when I first had this radio in my shop here, just poking around. So we know the signal reaching this tube is already distorted. Quickly. Look at the schematic here. Signal already reaching this tube is distorted. Oh, wow. Well, that's going way back here. Now we're getting into the detector zone. So I think what I'm going to do, I'm going to stop at this point. I really shouldn't, but you know what? There's a way to put audio into this. It's got an audio input, AF input. It's designed for this purpose. Why don't we put a signal in here and listen to it? Jim, you're just, sometimes you're so smart I can't believe it. Don't believe it. Okay, this will be my last attempt. Now, so I've got the audio input here. I've checked, and this is the grounded terminal. You can see the wire going to the chassis. So I've connected this to the grounded terminal on my supply. I don't have it on yet. I have the radio on. I'm going to take the antenna off so we don't hear that. Oh, I better leave it on at first. Take it off when we're ready here. So I'm going to turn this guy on here. Turn on here. Sometimes this does not produce an output, so we'll have to make sure that that's the case if we don't hear anything. So turn this up a little bit. And then I'm turning it up. Hello. Oh yeah, I don't have the speaker connected. So why wouldn't I connect the speaker at this point? I have to connect the speaker at this point. You take it off FM to get rid of the hiss. One of these controls up here. Up here. Okay, so I think it's on AM now. So we'll feed in the signal. What do we hear? not happy. This is not happy. Ooh, happy now. So I got the volume up really high over here, maybe. Yes, that is in full blast. So that's about half up volume. Oh, that sounds perfecto. Okay. Okay. Shut this off. Shut this off. One of these switches does it. Yeah, that one did it. Shut this off because he's upset. Well, okay, so my conclusion after all this is I barked up the wrong tree all day long. The audio was in good shape. Had I fed this test signal in right at the start, I probably would have moved on right away instead of dwelling on this. But that's okay. We still have this weird voltage thing happening here. I don't know what to make of that. I don't know what to make of it. So for now we'll ignore it, and tomorrow we'll investigate the detector, or the signal where it comes from the radio part through the detectors and then starts coming into the audio part, basically right around the volume control. See what we can find. Yeah, that's it. That's it for today. Gotta go. Thanks a lot for watching. Hope you're getting a kick out of this, and I sense I'm making progress. I'm senseless though. See ya.